Hey everybody, this is Larry. This is day 29 of the Leetcode Daily Challenge. Hit the like button, subscribe button, join me on Discord. Let me know what you think about this one. And today we have a hard problem. Happy Thanksgiving, I guess. They're like, you want to spend more time with your family, from Leetcode? And they're like, well, first you have to visit a cell, which already sounds kind of dubious. But also, we're going to give you a hard problem. So, happy Thanksgiving is what they're telling you. Anyway, kidding aside, all right, let's see. Let's get to it. I ate quite a bit. Maybe undid that fast a little bit, but no, but yeah, let's get to this one. So I could go sleep. A little bit tired, but maybe also just ate too much, kind of endorphins. So we'll see. Okay, so we have a grid, non-negative numbers, minimum time to require the cell row columns, which only when you visit greater than or equal to it. So you start the upper left, and you must go down, up, down, left, right. So you want to go down. Okay, so minimum time required to be able to visit the cell. Oh, okay. So that means that in a way, you can only go to that when it goes up. So here, you can only go to when it goes to 1, and so forth. Okay. I mean, I think there are two immediate dots for me. One is binary search. So because in a binary search, minimum time required. Yeah, in a binary search, you can just. Actually, do you want a binary search? I don't know if it's quite that, honestly. I mean, it feels like you can, but you still need, to move. So I actually don't know how. Not 100% sure on that interaction. But in any case, you can also just do a shortest path problem. I'm trying to think whether BFS is enough. And maybe it is, honestly. But I think like for these, it depends on how you think about it and how you define it. I think for me, to do it with Dijkstra is going to be just to be honest, it's easier to do Dijkstra because I don't have to prove anything, right? BFS requires certain, and even the 0-1 BFS that we did yesterday requires certain conditions to be true, and you have to kind of prove these invariants that we kind of did yesterday. I mean, I kind of went a little bit fast, but without needing to do it, you can just use Dijkstra's, and when you use Dijkstra's, you don't have to because it's greedy, and the conditions needed for Dijkstra is less strict, say. I mean, vaguely speaking, right? So okay, so then now we start upper level. It's gonna be 0. Is it always upper? Okay, yeah. They always sometimes fool you about this, I feel like. So yeah, so okay. So we start at 0, 0, and then while length of the heap is greater than 0, we have the current time or the distance. Let's call it the distance of xy is equal to. I don't know. I keep finding that. But yeah, this is just gonna be a shortest path problem, and I mean, minimum time to visit something. Shortest path for binary search is if it's on a grid or something like this, and I don't know, and just play around with it, right? Like sometimes people ask me like, how do I know if it's binary search or not? And I go, honestly, I just guess what if it's a binary search, and then if it's a binary search, how would I do it? And if I can't figure out a way, then it's not. Or well, not that it's not, but if I could figure out a way, then I'm like, well, if I figured out a way, then it is binary search. If I can't figure out a way, then maybe it's still binary search, but I'll come back later or something, So that's basically the. So it's not always like an exact science of like, oh, because of X, Y, and Z. No, I have to kind of explore it sometimes, especially if yeah, like I mean, if I've seen a similar problem before. That's a different story, but that's the thing, right? I think I'm kind of lazy today on this setup because I don't know why, but yeah, I don't know. Let's just go infinity actually, because this is the shortest path after all. Right. So then now this is just setting up Dijkstra's. I know I'm not really talking specifically that much about this because I think yeah. Yeah, I don't know. because this is just standard Dijkstra. I think this is a key thing that we kind of talk about in the past. If you don't know what I'm talking about, if you're wondering why this is, I need to do a video on this because I feel like I keep repeating myself and I could be just like, check out this video. But the short answer is that it, for a reason that today I'm a little bit speeding through, but basically, if you look at the heap, I guess we'll write it out first. Hang on, maybe it doesn't make sense because I didn't finish writing the rest of it. So we're just going through the up, down, left, right? So, and then now if the new location is within the grid, of course you have to make sure that it's within the grid. Then now the new distance is going to be equal to either d plus 1 or the minimum time to enter. The minimum time to enter is kind of a little bit awkward. It's either this or what's is already in the grid, right? Because the grid, I mean, you can think about it as just waiting until that time and then go or something like that. So I think this is the function for getting new distance. If new distance is less than distances of nx and y, then we are Gucci, and we want to heap push the new distance nx and y, right? And so, and I have to update the distance. The reason why we have this thing here, and I'm gonna, it's a little bit fast. I do want to do a video on this, but yeah, maybe we'll go over it. But I mean, we'll definitely go. I really want to do a video on this maybe next week or something. But because Thanksgiving schedule is a little bit awkward. Can't even say that out. But yeah, but the reason why is because here, you can imagine that, okay, ND, the first one, maybe, because let's say you have a diamond shaped thing, right? So let's say you have A, and this is ASCII art, like you have like a B and a C, and then they both, like it's basically a diamond thing, right? A D. You can imagine that A to B, maybe the length is like 10 or something like this, right? And then A to C, it's going to be longer, like 100, right? And then D, it's going to be, say, something big, and then maybe C to D is just 1, right? Well, in that case, you go in a Dijkstra greedy kind of way. You go B, you go, okay, it's 10, right? And then when you get to B, you go, okay, well, let's update the neighbors, right? So you update the neighbor, you go, okay, well, this is going to be 1,000,010. Okay, so the shortest distance is 1,000,000 to 10 at D, and then you put it into the heap. And then the next thing you do is going to be that, well, now 100 gets pushed into the heap, right? And then it gets to, well, actually, technically, 100 gets pushed in the heap earlier when you relax A, which pushed B and C into the heap. It puts 10 is the next one, and then you get 100, right? Fine. And you do the 10 and you get the 1,000,010 thing, but then you do the 100. And then now it does D, but then it goes, okay, well, the distance to D is now shorter, so we should update it. And then we push that to the heap. But note that in this way, D is pushed to the heap twice, right? And because, and there are a number of ways you can think about this, but one obvious way is that, well, now you're at D, you have two choices. You could be at D at 101 time or 1,000,010 times. Well, I think that's in a greedy, in a very easy greedy kind of way, you'll choose the one that's 101 and then just ignore the other one, right? So that's basically what this does. And as a result, because if you don't do something like this, then let's say D has like it connects to a lot of other edges, right? So E, F, G, I don't know, dot. Well, this branch is going to do its work, and then now it's going to push to Y, and then the second time it gets popped, and then it goes to Y again, and so forth. And then it just basically messes up your complexity, and this is where a lot of people time out without realizing why, that they don't understand it. And the reason why, when you learn it in algorithms class or something like this, or in the textbook, or even in certain YouTubes, they don't talk about this that much. I actually wrote this, I've been trying to use a different way of writing it so that it's more understandable, but the reason why they don't do it is because the heap that we have in the standard library is different from the heap that is in the algorithms form. In the algorithms class, the heap, you get something called an update function, right? which allows you to update this thing inside the heap. So you could update this node nxny inside the heap, and then basically you could think about, if you could probably practice doing this too if you really want to. It's just having a reference to it, and then you just go up and you heapify up and heapify down, which is how updates work, right? Pretty standard heap things if you kind of know how to do it, but but yeah, the reason why you get to do this now is just that it's slightly slower, but it's called lazy pop because there shouldn't be that many edges, and you end up with something like relog ye instead of relog we, and that's basic, and that's only twice as slow at worst because log ye is at most 2 times log we, right? Anyway, okay. I know that went really fast. I promise. Well, you could maybe watch it on like slower speed if you want, but I'll put out a separate video to kind of go over it in more detail because I feel like I've been saying the same thing a bit, and people still ask me the same thing a lot. Well, mostly because they didn't watch the earlier videos. Hopefully not because I didn't explain it well, but nonetheless. So anyway, yeah, and then now we just have to go return distances of what's it? -1, C -1. I didn't do one thing though. I don't know if this matters, but either way. Well, this is well, definitely I didn't handle the -1, so yeah. Should be Did I misunderstand this? No path from top left to the bottom right. Maybe I misunderstood. Oh. Only when the time you visit is greater than or equal to, right? Yeah, so why is there no path? How can there be no path? Did I misunderstand the problem? It's possible. There's no path from top left to the up. Why not? It just took 4 seconds. Alright, let me reread this. So basically, you cannot wait around. I guess that's the thing. I thought that you can just wait. I think that's why I kind of... so this is what the max function is doing. Okay. Well, now this is a different problem if you can't wait around. So the idea here is that here, you're not waiting around, but you're going back and forth, Okay, so maybe I don't need to do dice as a result, but it is a little bit clunky. 10 to the 5th is a little bit awkward. Well, I mean, I think the only case, the impossible case, there's only really one case, which is that if you cannot go anywhere on the first cell, right? The reason is because, yeah, I mean, if you can go anywhere on the first cell, then you can already just go back and forth, and then you can always do it at some point, right? This is a different problem. I misread this. I guess I didn't it is a hard, but I just didn't yeah, I just didn't think about this one, honestly. Okay, let's give it a little bit of a think. I mean, it may still be here, but I'm thinking that, so my second dot, or my immediate dot, would be to just kind of do it on the distance. But given that this is 10 to the 5th, you can't really do all times c times 10 to the 5th. That's going to be too slow, right? So, yeah. So if this function is wrong, I mean, I think we just have to maybe readjust this. So one thing that I would say is that if you can go back and forth, right? So let's say it's always possible. If it's always possible, and we'll assume that it's always possible as if you can get out the first cell, and if that's the case, because you can always just go back to the previous cell that you just came from, and then just go back and forth. So then now, actually, this is mostly right. What did I? I just want to double check my return values. Okay, my return values are better than they're expected, which is what I hope, because if it's the other way around, that means that I'm doing something more funky. But okay, so this means that, well, the thing is that I think I kind of talked about this a little bit in a previous, I think it was a contest problem like about 2 weeks ago or something like this, but maybe 3 weeks ago now, because time just, I don't even know what time is anymore. But basically, you can think about this board as a checkerboard problem, right? In that you have black cells and white cells, right? Like in a checkerboard or chessboard or whatever. Also, speaking of chess, let me know if you're watching the championship. I tried, but it's so early in the morning here in New York. But I don't know. Let's go. Ding versus Kakash, right? I'll talk about it more in the next video. But yeah. But anyway, we were talking about chessboard now. So as a result, that means that to go to the next one, it's going to be either D+1 or the grid, or so basically it has to be the next. So if D+1, I mean, I could just write it out real quick, right? There may be a slicker way to write it, but if D is even, then ND is equal to whatever so the max of D+1 or this thing, but with the same parity, right? Because if it's even, then the next one has to be odd. So how do I do an odd number, right? Actually, I mean, I think this is fine then, right? Because then now, okay, so the even is the even, and then this is 1. So that means that, okay, so that means that we can pre-process the grid is what I'm thinking of, right? So then now, so if I plus j is mod 2 is equal to 0, that means that this cell is an even cell, right? If this is an even cell, if grid ij is not equal to I plus j mod 2, then we just increment, right? So that's really the idea behind this, and I think that should be good. Okay, maybe not. Why is it 1 0 2 4? This should be an odd number. So the odd number, this is 0 1 2 or 1 2 3 4 5. So why that would never be 6? Why would it be 6? I mean, the -1 is easy to handle. I think it's just there's only one case. Okay, 0 1 1 2 4. So we are 0 1 2. This is not 4. Did I mess up? 0 0 0 1 0. Huh, did I mess up the grid? Maybe I... Zero one. Okay, so there should be 1 2. That sounds right. Though this is a 4, so did I mess up something? Why would... So the first row, just looking at first row, I put this as a 4. It should not be that you can get there in 2, which is why I'm confused. And D is equal to max of D+1. Yeah, I mean, the rest of the thing looks in line, so I don't know why this is. So something's funky. The funky thing is because I'm looking at the wrong cell. That is a really bad typo, actually. Okay, well, I mean, the idea is right, so that's good. And this math is kind of funky, and I didn't really explain that much, but basically I said about the checkerboard, right? But that means that whenever you go to a even square, well, and you're getting there in odd time, that means that the max, or if the minimum time is odd, then it doesn't matter because you can only be on that square at an even time, which is why that if it's not, the parity is different, then we make it the next number, which means that the parity now is right? So that's what the invariant is about this, is that all the even squares will be whatever, and all the odd squares will be part of that. Okay, so then now this is mostly good. The only thing is that can we get to the first cell, right? Yeah. And then, okay, so that we did this thing, right? So if grid of 0, 1, does it at least have 2 cells? Okay, fine. And it's not 1, or grid of 1, 0 is not 1, then we oh no, and this is an AND statement. Return -1. And this should be good. I mean, maybe I'm using an edge case, I'm lazy, but let's give it YOLO submit. Oh no, what I don't want to cheat yet. I mean, we're off by 1, so maybe I'm just like a little bit silly on one of the cases. That, I mean, and this is a even odd thing, so that means that I'm really wrong on something weird. I mean, this is unfortunate. Okay, well, I guess we'll still put it in. This is what happens when you rush. Okay. But, I mean, this is just a very weird wrong answer, I think, because the odd even is wrong, right? So that already... D+1? Maybe the D+1 messes it up? Shouldn't be, because it always respects that. Yeah, it shouldn't be. Is that number 68, whatever, coming somewhere? Not the last number anyways, but I actually don't know, but like if it was just off by more, then it is what it is. But I don't know how to get an answer where the parity is wrong. I think that's my problem. Because D is... okay, let's see. Okay, I mean, this is wrong, but why? One zero. I mean, at least that's is that in the first case? I mean, this is a 1. D+1, okay, so, okay, xy, d, grid of nx and y, alright, 0, 0, 1, 0, so it goes down, goes from 0 to 6, 1, 0, 1, 0, 1, it's 6, then this should be 7, so, and is this on, which problem is it? Is there some like weird thing that I'm missing? Is this, just want to make sure that this is... nope, this is on the first one. 1 plus 0 is odd. Grid of ij is 5, right? So why did it... I don't get it. Why did it increment? Yeah. 0, 0. Am I going crazy? I mean, this is definitely a smell. It's a different thing, but it's related. 1, 0 is 5, but oh my god. Oh, Larry, what are you doing? I forgot the mod 2 part on the left. Okay, well, I mean, something. Okay, Some days I'm just driving myself crazy. On silliness. Maybe I rushed this a little bit though, so I don't know. Okay. Look, you can't be right all the time. I mean, and for me, I cannot be right most of the time. So yeah, that's pretty much it. Yeah, what did I did one last time? I don't know. This one is actually right for the thing, but I don't know. Oh, I didn't do I did it a different way, so maybe there was a typo there or something. It seems, but it seems like the idea is mostly the same, except for this time my code is actually much tighter, I think. But yeah, I actually don't remember this though. I mean, it's a year and a half. It'll be crazy if I remember. And the wrong answer is just because of this silliness. And it didn't affect the example cases, which is wild, but it is what it is. But yeah, I mean, this is just standard heap, right? You have a linear thingy processing, but otherwise, and the key thing is noticing this part where you cannot go back and forth from your previous step. And then here, this is just all of v log e, right? So yeah, make sure this is all v log e. Again, with proper update, this will be v log v, but it is what it is. Yeah. That's all I have for this one. Let me know what you think. I will do a dice drill thing in the future. Thanks for watching. Stay good, stay healthy to your mental health. Have a great rest of the week, whether you thanks you're giving or not. And I'll see you later and take care. Bye bye.